Okay, I just want to offer an alternate solution for number 177a that involves completing the square, and I'm going to show it here. Instead of, when we're looking at this question, instead of starting with the x-intercepts, you can also start by finding the vertex through the graphing form of the equation. So I'm going to show you what this looks like by completing the square. So you're going to take the equation and you're going to try to find the nearest perfect square. So you're going to take the first term, which is x squared, and you're going to put it here. You're going to take the middle term and you're going to break it in half. You're going to put half here and the other half here. And so this is going to become x plus 4 by x plus 4. And then if this is a square, and you can see that the side lengths are the same, then you can figure out how much value would fit inside this fourth box here by doing 4 times 4, which is 16. So this is equal to x plus 4 squared, right? That would be x squared plus 8x plus 16. Okay, however, the target value was actually up here. We're supposed to have 12 at the end. So this square that we're working with is, it's too big, meaning the number on the end here has too much value. So we have to make an adjustment. And we have to, after we compare it to the target value, which is 12, we have to go, oh, well, 16 is 4 units larger than 12. So we have to subtract 4 to get from the perfect square value to the target value. So I'm going to go ahead and subtract 4 units of value. And so this is going to become x plus 4 squared minus 4. And now I'll see that that is equal to x squared plus 8x plus 12. So this is what I wanted all along, x squared plus 8x plus 12, and now I've rewritten it in graphing form here. So I'm going to take that, and I'm going to write it as my, my blank here. So in graphing form, y equals x plus 4 squared minus 4. And from there, I can spot the vertex, which is at -4, -4. Okay, so that's great. Okay, now, in order to find the x-intercepts, and you know what, I'll show this little shortcut too. Anytime you have an equation in standard form, the y-intercept is always going to be the number at the end. So that's going to be 12, so 0, 12. Because the y-intercept is when x is equal to 0. So if I plug in a 0 here and plug in a 0 here, I will see that these would just go away, and you'll get y equals 12 when x is 0. So already I'm pretty quickly moving through this problem using the completing the square method. But now I find myself here where I need to figure out the x-intercepts. So what I'm going to do is I'm going to take this completed the square form, this graphing form, and I'm going to set it equal to 0, which is what I always do when I'm finding x-intercepts. So I'm going to move down here, and I'm going to say, okay, if y, which is equal to x plus 4 squared minus 4, if this is now equal to 0, I can ask the equation, please tell me what are the values of x that make y 0. So I'm going to start to solve for x. So this is going to become x plus 4 squared equals 4. And then I'm going to take the square root of both sides. And this is going to give me two possibilities. Either x plus 4 is equal to 2, or x plus 4 is equal to -2, because 2 and -2 are both square roots of 4. So now I can see that I'm going to get two answers. One is that x is equal to 2 minus 4, which is -2, so that's the first possibility. Or I'm going to get that x is equal to, if I subtract 4 from both sides, -6. So these are now my x-intercepts, right? And this is all because the x-intercepts are at y equals 0. That was kind of how I started this whole journey. So I've got x-intercepts at -2 and -6. So -2, 0, and -6, 0. So the completing the square method, in my opinion, sped things up a little bit, made it quicker, and now I can draw the same graph as before, where I have points at -2 and -6, y-intercept at 0, 12, and a vertex at -4, 4, and so now I'll be able to connect those together into a parabola. Okay, when we come to question B, I have a new quadratic that is now in graphing form. So if I'm going to try to find the x-intercepts, the first thing that I'm going to do is I'm going to set this equal to 0. So if x minus 4 times x plus 2 is equal to 0, then 0 product property tells me that either x minus 4 equals 0 or x plus 2 equals 0. So if x minus 4 equals 0, then x is equal to 4. That's my first x-intercept. And if x plus 2 is equal to 0, then x is equal to -2. That's my second x-intercept. So x-intercepts are going to be at 4, 0, and -2, 0. All right, if I want to find the y-intercept, as always, the y-intercept, I'm going to change colors here. The y-intercept is always at x equals 0. So I'm going to find y when x is 0. I'm going to plug in 0 for x. I'm going to multiply that out. And of course, this is going to give me that when x is 0, I have -4 times 2, which is -8. So that's my y-intercept. When x is 0, y is -8. Okay, now I'm ready for my vertex. Okay, the vertex, I'm going to switch colors. Okay, the vertex is when the vertex is always halfway between the x-intercepts. So it's going to be at the average of the x-intercepts. Okay, the vertex is at the average of the x-intercepts. So it can be helpful to kind of sketch out what we have so far. So we've got a y-intercept at -8, so down here, 0, -8. And we've got x-intercepts at 4 and -2. So 1, 2, 3, 4, one here, and one at -2, okay? So it's looking like the parabola will be something like this. And if I draw a line down the center, it's going to be here. That's where the line of symmetry is going to be. So the vertex is going to be like right in here. So I need to find the halfway point between here and here. And I can tell by looking at it that it's 6 units across. So like it's going to be 3 this way. It's going to be 3 this way. Because -2 and 4 are 6 units apart. So I'm just going to go 3 units to the left of 4 and 3 units to the right of -2. And I will see that this is the line x equals -1. So that's what this value is here. +1. Okay, so that means the x-coordinate of the vertex is going to be at 1, and then I want to figure out what the y-coordinate is. So I'm going to plug in x equals 1 and get y. So here we go, y equals, and I'm going to go back to the original expression of the equation, right? X minus 4 times x plus 2. So x minus 4 times x plus 2. But of course, I want to plug in 1. And I'm running out of space here, so let's move this. And so this is going to be equal to -3 times 3, which is equal to -9. So that's my y-coordinate of my vertex. So this answers the question here. When x is 1, y is 9, -9. And that goes here. And then lastly, to get the graphing form of my equation, I can go from vertex directly into it and write it as y equals x minus h, which is 1, plus k, which is negative 9. So I'll throw a negative 9 there. X minus 1 squared minus 9, or x minus 1 squared plus negative 9.